everyone. In this video, I'm going to be walking you through molarity calculations. So first off, molarity is a unit of concentration in chemistry. Concentration is simply how strong or weak is a particular substance. For instance, anytime we've used a dropper bottle in lab, it always has a number and then the letter M after it. That is representative of molarity. Now, when we determine the molarity of something, we simply say molar. So you can have 0.1 molar HCl. You can have 1 molar HCl. You can have 8 molar HCl. So these concentrations represent how strong or weak a substance is. For instance, something with a much higher molarity is going to be stronger and much more dangerous if you were to get it on you than something with a lower molarity or a weaker concentration. So molarity is a concentration unit of a solution. And it is expressed as moles of solute dissolved per liter of solution, right? And how we represent that in our molarity equation is molarity equals moles of solute per liters of solution. And this is our equation for molarity. Another way that you can write it is a little triangle of how we did our density equation. So you can make a little triangle and you can write molarity equals moles over liters. Now, a couple of things I have to mention before I start is that we absolutely have to have these units in order for this equation to work. So if I give you grams, you have to convert it to moles. If I give you milliliters, you have to convert it to milliliters. Now on this page, which is page 8, I do have a couple equivalence ratios here to remind you before you work on these 5 practice problems. So don't forget, a mole of something equals the molar mass of that something. So you will need a periodic table in order to complete these. 1 gram of water is equal to 1 milliliter of water. So if I was to say 100 grams, that equals 100 milliliters of water. And then finally, our equivalence ratio for liters and milliliters is that 1,000 milliliters equals 1 liter. So in order to get to these desired units up here, we have to use that information that I've highlighted. So we're going to do example 1 and 2 together. So this question is asking for molarity, so we're solving for M. And sometimes I might have you solve for liters, and other times I might have you solve for moles or grams. So you'd have to solve for moles and then convert to grams. Alrighty. So it says, what is the molarity of a solution which contains, here's grams already, 55 grams of NaCl and 0.75 liters of solution. So here we have liters. From the grams, we're going to be able to convert it into moles, and then we can plug it in. So we have molarity equals moles over liters. We already have our number for liters. It's 0.75. And we're going to divide our number of moles by that, and then we'll have our answer. But first we have to convert. So back to unit, 9? We have 55 grams. That's our starting unit. We have NaCl. And then we need to convert it. First step always in a conversion is you put the starting unit in the bottom of the conversion factor so it can cross off. We have grams of NaCl in the denominator here. And we know that the grams of something is always equal to 1 mole of that something. Now we need to check our periodic table to determine the molar mass of NaCl. So we are going to add up the mass of sodium, which is 22.99, and we're going to add it to the mass of chlorine from the periodic table, which is 35.45. And you should get 58.44 grams. And then we're going to divide 55 by that answer, or by 58.44, and you should get 0.94 moles. Then we take this number and we get to plug it into our molarity calculation. So it's 0.94. And you're going to divide 0.94 by our number of liters, which is 0.75. And the molarity of a solution which contains 55 grams of NaCl and 0.75 liters of solution is 1.25 molar NaCl. Sorry, that's very messy. But your unit here is just a big M, and then you always want to include the substance, and I ran out of space, so it looks a bit messy. But it is 1.25 molar NaCl, or sodium chloride. Alrighty, so the next one, example 2, it says, household laundry bleach is a dilute aqueous solution of sodium hypochlorite. Ooh, how about that one? How many moles? Oh, this time we're solving for moles. I'll just put a little question mark there. Actually, I'm going to make this a different color. Make it light blue this time. How many moles of solute are present in 1.5 milliliters of 0.70 molar sodium hypochlorite? For this one, honestly, I'm not as concerned that you have the correct compound since I'm asking you for the number of moles. So you don't have to really worry about the type of substance that this is. It's okay. Don't stress about it. Alrighty. So for this one, since we're solving for moles, let's take a look up here at our little triangle, actually. So if we are solving for moles, okay, we're looking for this, then it's molarity times liters. So I'm going to write that down here. We're going to have moles equals molarity times liters. Now we're in milliliters here, and we do have a molarity. So we'll plug our molarity in first. We have 0.70 is our molarity. And then we need to convert 1.5 milliliters to liters. Now, in all honesty, if I have you guys show work, I am not really requiring you to show the conversion, like the molar mass conversion up here. I will want to see this molar mass conversion, but if you just want to count decimal places to convert from milliliters to liters, I'm utterly okay with that. So if you remember, King Henry died by drinking chocolate milk. Milliliters is at the milk portion, and liters is at our base unit. So we would go 1, 2, 3 hops to the left in order to get from milliliters to liters. So if we go 1, 2, 3, then we have 0.0015 is our number of liters. If you want to do the conversion, you're welcome to do the conversion as well and just divide it by 1,000. So then we plug this into our calculator. 0.7 times 0.0015, and you should get, actually I'm gonna try and make this neater than the first one, but you should have gotten 0.00105, and then don't forget your unit. And that is it. So there's only 5 of these problems. You just plug them into the equation and solve. Just again, be sure that they are all in the correct units, moles or liters, or have a big M next to the number. And let me know if you have any questions.